Hey everyone! Today, or in this video, we're going to talk about the heart and what the heart is, and we really need to understand how the blood flows through the heart and the various heart structures. So if you can think of the heart, it is basically, helps if I have my pen, it is basically a two-sided pump. You have a right side and a left side. The right side, the purpose of the right side is to collect blood from the body and to pump that blood to the lungs. Specifically, I want my blue. Specifically deoxygenated blood from the body, and it's going to pump that deoxygenated blood to the lungs. And when it gets to the lungs, the whole point of that is to, that's a terrible inclusion sign. The whole job is to collect oxygen and to remove carbon dioxide. Now, why is this blood deoxygenated? Well, it's coming from the cells. So when the cells do their metabolism, when they're doing their cell stuff, the cells use oxygen. So the cells deplete the blood of its oxygen, and then at the same time, carbon dioxide is that byproduct of the cellular metabolism, and it needs to get rid of it. It's waste. So the cells take the oxygen, and they give back the carbon dioxide. So it turns the blood deoxygenated. Now the blood still has something like 70% O2 in it. So it's deoxygenated. It is not completely without oxygen. All right? Now the left side, so it pumps this deoxygenated blood to the lungs to pick up oxygen to get rid of carbon dioxide. And now the left side's job is to collect that blood from the lungs to pump that blood to the body, and that's oxygenated blood. And it's going to give that oxygenated blood to the body, so the cells can pick it up and use it for cellular metabolism. So we have the two-sided pump. You have the right side and the left side. Now here's this crazy drawing I've just done. Where is my yellow? I found that yellow is the best color. Oh, for heaven's sake. There it is. Okay. All right, so let's talk about how that blood flows through the heart to the lungs, back to the heart. You have here your... Oh, wait, I want to make sure I'm on a good layer. You have your superior vena cava and your inferior vena cava. And the whole job of the vena cava is to collect blood from your body and bring it back to your heart. And so the superior vena cava collects it from your head, right? Anything above your heart. The inferior vena cava is going to collect it from your body, right? And then it goes into the right atria. Your right atria also collects blood from the heart circulation itself. So your heart's muscle, that's what this pink is. Your heart's a muscle, and your muscle's doing muscle stuff, and it requires oxygen and nutrients in order to do that work. And so the heart muscle itself has its own blood supply. It's called the coronary arteries. And so through the coronary veins, because coronary means heart, the coronary veins return that used blood, that deoxygenated blood from the heart itself back to the right atria. So it enters that. So the right atria has a few different purposes. It's a collection point. It's also essentially a measuring cup to where we can make sure that we get enough blood, not too much, not too little, to fill the right ventricle so that we get good cardiac output. All right? Now the right atria, as the left atria does as well, the right atria also contracts. And I want to talk real quick about, we're going to touch on this. It's called the Frank Starling law. And without getting into too much detail, because that would take far too much time, what this law says is the greater, and this is the greater than sign, the greater the stretch of your heart muscle equals the greater the contraction of that muscle, or the greater the force of contraction. So the harder it's going to pump. And so when we stretch, so when the right atria contracts, it's going to fill this is your right ventricle. It's going to fill the right ventricle with blood. And that filling is going to stretch that muscle wall. And it does it up here as well, right? So all this is going to stretch. Now, when that stretches, it's going to recoil, and that recoil is going to help increase. Now, this muscle contracts as well, right? So the right ventricle muscle is going to squish, it's going to contract. But this stretch is going to help it contract with greater force and greater efficiency. There's a condition called, and this is just, as long as we're talking about it, atrial fibrillation, where basically the atria are just quivering. And so you lose that filling power of the atria. So you lose that stretch of the ventricle, which means the contractile force goes down in AFib. And I've read about AFib is that it can decrease your cardiac output. That's how much blood you're pumping, by up to like 25%. That's a pretty big amount. All right. Now, your blood is going to pass through, from the right atria to the right ventricle, it's going to pass through the tricuspid valve. And it's called a tricuspid valve because there are 3 different leaves to it. And these leaves, these little valves, are going to prevent the backflow from the right ventricle into the right atria. If it backflows, it's going to go back to our body. That's deoxygenated blood going back to our body. We don't want that to happen. We want to direct that blood into the lungs where it needs to go. So these valves close shut. And the way they do that is they're connected by these cords called the chordae tendineae. And those are connected to papillary muscles. And those muscles get contracted because they're attached to the ventricular wall. And when they contract, when the ventricle starts to contract, these force these valves shut so that we don't get that backflow. So then all of that force is going to push open what we call the semilunar valve. And the reason they call it semilunar is because it looks like a half moon. That's what they thought when they first started dissecting people. It looks like a half moon. So we're going to call it semilunar. And this is called the pulmonary semilunar valve. Remember that pulmonary means lung. So that should tell you where this leads to. It goes into the pulmonary trunk. And that trunk takes a left and a right turn, it bifurcates, and this goes into the right pulmonary arteries and the left pulmonary arteries. Now, why are these arteries? They're arteries because arteries always go away from the heart. And you'll get people that say, well, arteries always carry oxygenated blood except for the pulmonary arteries because they carry deoxygenated blood. I always disliked that rule because it confused me, because there was always that one that took the deoxygenated blood. Same thing with veins, right? For the oxygenated blood. So I always remember that arteries always carry blood away, and I remember that for away. Okay? So the pulmonary arteries transport that deoxygenated blood, that's why it's blue, to the lungs. So they go do the respiration, right? In the alveoli with the capillaries that cover the alveoli. So they do the pulmonary respiration, which is gas exchange. So they get rid of the carbon dioxide. They pick up the oxygen. And now they need to return back. And I'm going to change this to green so we can differentiate. So now we have oxygenated blood returning back to the heart. And it's going to return back to the heart via the pulmonary veins. Now you can say that veins, veins always go towards the heart. Right? Your vena cava veins are great big veins, and they go towards the heart. The pulmonary veins go towards the heart, and they're going to go into the left atria. And just like the right atria, the left atria acts as a collection point, acts as a measuring cup, and it contracts to help fill the left ventricle. That blood's going to cross or pass through the bicuspid valve, or more accurately, the mitral valve. Now, the reason they call this tricuspid is got 3 leaves, like we talked about. This is called the bicuspid because it's got only 2, but that's not in everybody. So they came up with mitral valve. I have no idea where that comes from. I should have looked that up. But you should really get used to calling this the mitral valve. The way I remember this, though, is we always start on the right side of the heart, we go to the left. I'm going to try something, and then I might buy it. I hope that helps you. It helped me. Help me keep that straight. I'm going to try something, I might buy it. So we're going to pass through the mitral valve into the left ventricle. Okay? Now look at the difference in the thickness of the ventricular walls that I've drawn, and I've exaggerated it, right? But not by much, to be honest with you. Why is that so? Well, look at where the ventricles have to squish to force this blood. Where do they have to contract to push this blood? The right ventricle is only going to the lungs, which is right on the exact same side at the same level on either side of the heart, right? So it doesn't have very far to go. The left ventricle has got a far greater distance to transport that oxygenated blood. It's got to go to the head, it's got to go to the tips of your fingers, and it's got to go to the tips of your toes. So it needs far more force behind its contraction. That's why it's a thicker muscle. It's got more work to do. So that left ventricle is going to start contracting. That contraction is going to close the mitral valve so we don't get backflow into the left atria. And it's going to go and force open the aortic semilunar valve. And I totally forgot to color this red. But this is the aortic semilunar valve, and that should tell you where we're going to go with this blood. It's going to push it up into the aorta. You have 3 different parts to your aorta. You have your ascending aorta, it means it's going up. You have your aortic arch, that's this thing, and then you have your descending aorta. And the job of the aorta is to transport blood to the rest of the body. You got these little notches coming off. These lead to your subclavian, or below the clavicle. That's why you got clavicles there. Those branch into the brachial arteries. Those are the ones that feed your arm. Your brachial arteries split into your radial artery and your ulnar artery to feed your distal portions of your hands. Another one of these branches goes up into to turn into your carotid arteries, which is going to feed your neck and your cervical spine and your head. And then you have the descending aorta, which is going to go down into your abdomen to where you have your abdominal aorta, and then that branches into your iliacs, and then your, oh my gosh, why am I blanking? Femoral arteries. Good grief. All right. I worked all night. And so that's the whole job of the aorta. So that's essentially it. That is how the blood is going to flow through the heart via the 2 different pumps. I hope this helps. Let me know if you have any questions, and that's it for now.